Hi, this video is on trust funds and perpetuities in the finance unit of general maths. So you're learning how to understand what trust funds are and how they work. You should also understand how a perpetuity works by the end of this video, and to know how to use this formula, R equals IP, or different variations of it, to calculate the maximum size of a perpetuity payment, and also the interest rate needed or principal amount needed, depending on the question. Okay, so we'll start with the definition. Trust funds, funds which involve a lump sum investment which continues to earn interest and pays out regular sums into the future. So examples of that might be where sometimes you hear about parents setting up trust funds for their children. So they'll put a certain amount of money into the bank, usually into some sort of high interest account that gains interest. And then over time, that child is able to draw money out regularly like a salary. And providing they don't take too much out, then there'll be sufficient money in there to gain interest, and they'll be able to keep drawing that money now forever if it's a perpetuity, if it's designed that way, so that it never runs out of money. But if you take too much out, then your principal will diminish to the point where there's nothing left. But we're going to be working out later exactly how you would set that up so that it never runs out of money, and that's a perpetuity. Okay, so similar to annuities and arrears, so you have a lump sum first. In this case, that would be P here, and then you can draw money out, which would be like the repayment when you're paying off a mortgage, for example. N is the number of periods remaining, again, just like in annuities and arrears. So here's an example. Margot's will requested that $50,000 is invested in a trust fund, so each year a promising young artist will be given a bursary. A bursary is like a grant. It's free money which is given to a person, often for study and things like that. So in this case we've got for assistance with higher level study. Fund is to last for the next 25 years, so it has to last for that amount of money. Find the value of the bursary if the money is invested at that amount, adjusted annually. And the first award is made at the end of the first year. Okay, so we're going to do this algebraically first of all, which means we need our annuities in arrears formula. P is equal to $50,000. R we don't know. It says find the value of the bursary, so we don't know how much is going to get paid out each time. I is 0.064 adjusted annually, so that would be like dividing by 1, so we don't need to do that. And N is 25, it's going to last for 25 years. So first thing to do is to write out your formula, and next is to substitute in each one of these values, and then we're going to solve for R. So we get 50,000 equals R times 1 minus 1 plus 0.064 to the minus 25 divided by 0.064. Okay, if you calculate that part, it comes out at 12.31155. And then we're going to get R is equal to 50,000 divided by that. And you can see we get $4,061.22, the nearest cent. So what we've worked out is that if you had $50,000 and you invested it in an account that paid 6.4% per annum, you could take out $4,061 a year for 25 years before your money ran out. So the bursary would be able to be $4,061, and that would last for exactly 25 years. We'll look a little later at what we would have to do to make sure that it lasted forever. Okay, here's a different example. Simon has a $400,000 trust fund. Lucky Simon. Interest is paid at 8% per annum, compounded monthly. If he receives a monthly payment of $3,500, how long will the fund last? Again, we could solve this algebraically. It doesn't state to do it algebraically, so we'll use the calculator this time. Okay, so the question is how long. So we're trying to find N. I is our percentage, that's 8% per annum. We're starting our principal value with 400,000. How long will it last? So that's the idea is how long will it last till it goes down to 0, so our final value is 0. He's taking a regular payment of minus 3,500, and it's compounding monthly, and he's drawing monthly, so it's 1212. Now because this is annuities in arrears, it should be at end as well. If we calculate n, we get 215.97 or 0.98 periods, that's months. So we get 215.98 months, and if we want to turn that into years, well, 215.98 divided by 12 gives us 17.998, so it's practically 18 years is how long it would last to the nearest month. Okay, next question. What we're going to look at now is a perpetuity. Now, perpetuity is where you take a trust fund but you make it last forever instead of running out of money. So we can do this because in this case the regular payment is equal to the interest made, and therefore if you never take out too much money, it'll always stay with that amount of money in the bank that you started with. A nice easy example maybe to start with would be to think, well, if you had $1 million in the bank and it paid 10% per interest, 10% interest a year, you would be able to take out, or at the end of the year rather, you would have 1,100,000 because it's increased by 10%. If you were then to take out every year 100,000, it would always go back to 1 million, which would then grow by 10%. You take your 100,000 out, grow by 10%, take your 100,000 out. So as long as you don't take out more than 100,000, your money will last forever. So the idea here is that if you took out exactly 100,000, it would last forever. If you took out 120,000 every year, eventually the amount of money you would have would disappear. If you took out less than 100,000, then not only would your money last forever, but the lump sum would actually continue to grow. Now, there's a formula here that you can use, this perpetuities formula. P equals R over I enables us to just calculate how much money that is. So P here, the size of the fund, but that's like the principal amount that we start with. For example here, $1 million. R is the size of each repayment. So in this case, we're working out that it's $100,000, and I is the interest rate per period as a decimal. So 10%, which would be 0.1. Now you can rearrange this, and there's a nice handy way to remember it. You can use one of these handy triangles to help you remember. So R is equal to I times P, I is equal to R over P, or P is equal to R over I. And a nice easy way to remember it, just think of a triangular tombstone with RIP written on it, and that should stick in your mind quite well. Okay, Margot's will has requested that $50,000 be invested in a trust fund. We had a look at this question earlier, but now we're going to change it so that it lasts forever. How much can the award be? So what's the most that she can give away and have this amount of money never dip below $50,000 if it's earning 6.4%? So we're going to use that formula, R equals I times P, that we just looked at here. R equals I times P. The repayment amount is going to be the interest, which is 6.4 as a decimal, so 0.064 per period, and it's annual, so it's divided by 1, and then multiplied by P, which is $50,000. If you do that on your calculator, now we can see there that you get $3,200. So if Margot sets it to be $3,200, then that money will never disappear. So 50,000 will grow by 6.4%, giving you $3,200 or $53,200. Take $3,200 out every year, and you'll always have $50,000 left. There is another way to solve this using the TVM solver, which is this here. So if we put in 6.4% here, and we start with $50,000, and the thing is, the trick here is we're trying to work out the payment such that the final value stays 50,000, so it remains at 50,000. N is just a very large number, so we're going to say that this happens forever is the idea. So N, I've just stuck in a big number there where we've got 1 million. And payment is what we're going to work out. Not forgetting that PYCY here is 1 because it's happening annually. There you go, hit payment and we get $3,200 just like we worked out there. Okay, here we've got $250,000 invested in a quarterly perpetuity fund at 5.8% per annum compounded quarterly. How much will each quarterly payment be? So we'll go back to our triangle here. You've got R is I times P. We know what P is, 250,000. So I'll type that actually. P is 250,000. I is 0.058. Now it's per period, so divided by 4. And R we're trying to work out. So we want R equals I times P. So R is equal to 0.058 over 4 times 250,000, and we're going to get a value of $725. So there we go. That's trust funds and perpetuities. So trust funds are annuities in arrears. Perpetuities are designed to last forever. That's what in perpetuity means. And the formula R equals IP relates the principal, interest rate and repayment, and you can use that handy tombstone triangle image to remember how all that works. Okay, there we go.